Hi everyone, it's week 12 in Business 2220. Instructor John here. And this week we're having three videos, two that I've done in prior semesters, and this one is brand new for this semester. And so the problem I've selected is problem 9.27 you can find on page 362. The other two I'm going to leave in. They're from prior semesters, and the page references will be wrong, of course, but I'll list. In fact, one of the two problems no longer exists in our current version of the textbook, but you'll get the idea without having to read the problem. I'm leaving it in. More practice, the better, is my theory. This problem is found in the textbook. As I say, it's 927. You can find on page 362. And we're asked to determine if the banks in Ohio are doing better or worse than the other banks in the Midwest. Now, I'm not going to get into what the actual statistic is, percentage of delinquent loans or some such thing. At any rate, the Midwest average is 3.5%. Now, the fact that it's a percent shouldn't confuse you. It's not a proportion problem. This is just a number, 3.5. It's the ratio of the number of delinquent loans to total loans or some such. But this is again not a proportion problem. We'll do that in another video. But the number 3.5 is the statistic we're interested in. The Midwest average is 3.5, and the bank regulators claim that it's in Ohio higher than that. And they want to do a sample and test to see whether that is true or not. Well, okay, the first step in hypothesis testing, we know, is to set up a null hypothesis and an alternative hypothesis. Well, I've got one here for you, in the interest of time. The null hypothesis is that life is as it is, 3.5%. Ohio's no worse, no better than maybe even could be better than the Midwest average. So Ohio, nothing to worry about if the null hypothesis is true. The alternative hypothesis, the one we would like to prove or disprove, is that it is greater than 3.5%. What this means is that if we have statistical data that says we should reject the null hypothesis, that Ohio meets the Midwest average, then we have no alternative but to accept the alternative hypothesis that it's greater than 3.5%. Now, the book asks us what's a type 1 error and what's a type 2 error in this particular case. Well, if we review the definitions that you can find on page 346, pull those in for you. Here we are. A type 1 error is that we should reject the null hypothesis when in fact it is true. Well, what's that mean in this particular case? Well, it means that the banks are, again, save some typing, the banks are forced to improve when in fact they are as good as other Midwestern banks. Let's think about that. If the null hypothesis is true, that means there's nothing wrong with Ohio banks. They're doing as well as Midwestern banks. But if we reject H0, reject that statement, then we accept the fact that they're worse than the rest of the Midwest, then we're going to force the banks to go make a bunch of changes when in fact they really don't need to. What's the type 2 error? Well, it's the opposite, that we do not reject H0 when it is false. Let's say we accept H0, that the Ohio banks are doing just fine. Well, we're rejecting, that means that they're not going to have to improve when really they should. So that's the cost of making a type 2 error. Now, if you're a bank, you don't want to commit a type 1 error, because that means the banks are going to have to go through a lot of rigmarole just for nothing. But if you're a regulator, you're not so much worried about that. You're going to have egg on your face if you don't require them to improve when in fact they should. So, where you stand in this debate depends on where your interest in the outcome. Okay, to do a good hypothesis test before we do anything else, we ought to set our standard. Now, what is our alpha value? How certain do we want to be that we're not going to make a type 1 error? Well, if I'm a bank, I want to be pretty certain that we're not going to be put through hoops we don't need to be put through. If I'm a regulator, maybe I want to loosen that up a little bit. But the textbook says we're going to accept an alpha value of 0.01, 1% chance of making an error. The next thing we do, because we're going to use the critical value test, is to convert this alpha value of 0.01 into a critical value. Well, what we can do is go to table 6.4, appendix rather, A4. I can find it here. I've lost my page. And you can search through it with how many degrees of freedom do we have? Well, in a minute we'll look at the data. We have 7 data points, so we know the degrees of freedom would then be 1 minus that, or 6. So if we go to page 640 and look at the degrees of freedom 6 line and go over to 0.01, we get a value of, where am I here? T.01, 3.143. So T critical equals 3.143. Okay, that's 6 degrees of freedom. Check that. Yes. Oh, I'm sorry. Yeah, that's right. I thought I was going cross-eyed. 3.143. Okay, that's our critical value. Now let's look at the sample data. I'll bring that in. Here we are. And we need to get some basic statistics about that data. Well, first of all, what's the average of this sample, X bar? Average of all this data is 6. Is standard deviation of these numbers is 1.852, and the n, as we said, is 7. Okay, now we need to come up with a test statistic. What is our test statistic? Easy for you to say. Well, it's equal to the difference of our sample average and the assumed average, 6 minus 3.5 in this case, divided by the standard deviation, which itself is divided by the square root of n. Now, we know that we're dividing by the square root of n because this sample standard deviation is really the standard deviation of the population. If we draw a random element from that population, the standard deviation gives us the probability of getting a particular value. Well, we're not interested in that. We're interested in the standard deviation of the sample mean. If we do this experiment many, many times, as we've done in the simulation exercise, if we do this sample many times of 7, we're going to get a different average value every time, a different mean every time. And the standard deviation of that collection of sample means is equal to s divided by the square root of n. All right, so what's that going to turn out to be in this particular case? It's equal to our x bar rather, minus our assumed value of 3.5, all divided by the sample standard deviation divided by the square root of n. Woo! Didn't like that. They put a parenthesis on the n for me. 3.64. Okay, now what we do is we compare 3.64 again, 3.62 rather, against our critical value of 3.143 and say, that's greater than the critical value. So we must reject H0 and accept, we must, because the probability of getting this result, if H0 is true, if the Ohio mean is 3.5, the probability of getting this set of samples with a value, an average of 6, is pretty darn small. It's a lot less than 1% anyway. So we reject H0, and that means we must accept HA and put the banks to work to clean up their act because they're not doing as well as they should. Now, another interesting thing to do is to convert this test statistic into a probability. We know it's greater than 0.01, but what is the probability of getting this set of sample data with an average of 6 if the null hypothesis is true? Well, that's converting this value into an alpha value. And so T alpha is going to be equal to, now I could go back to the table and look up 3.62 on the 6 degrees of freedom line. Well, it's T005 is 3.707. And the book, in fact, tells us it's 0.006. So we could go with 0.006, but let's just, for the fun of it, T inverse, T distribution of this value with 6 degrees of freedom and one tail. Remember, we're doing a less than, so this is a one-tail problem. Gives us a T value of 0.055. The book said 0.006. 0.0055 rounds to 0.006. So the probability of getting this sample result is 0.006, 0.6%, which is less than 1%. But notice it's greater than 0.001, 0.1%. So there is a level. We can't say that there's extremely strong evidence if we use the criteria that we find on page, wherever it is, end of section 9.1 as I recall. Let me just see if I can find it here for you. It's here somewhere. I never can remember the page numbers anymore. No. Well, I've given you the reference somewhere else in the world, but I can't find it here. Oh, here it is. It's on page 356. If it had 0.001, we'd have extremely strong evidence, but we could only say that this is very strong evidence that the banks ought to clean up their act. Okay, that's it. There are 2 more videos coming, and I encourage you to look at all 3 of them and see if you can figure this stuff out. Thanks a lot. See you online.